Hello, Math 1093. This is Dr. P with Don't Be Afraid. Okay, I feel like anytime someone tells you not to be afraid, it's like a warning. So I've given this problem here. You'll find problems like this in the My Math Lab homework for section 3.5. So I've asked you to evaluate the cosine of this thing. What is all this? The cosine of the arcsine of negative 2/3 plus the arctangent of 1/4. Okay, so what in the world does this even mean? Let's just think about this for a minute. What does this mean? What does this mean? Because this is a good illustration of a general principle about how to deal with stuff like inverse sine and inverse tangent. All right, so just as a reminder, I realize I keep doing this, but sine takes angle measures and spits out a y-coordinate or a ratio of y to r. All right, and the tangent function takes in angle measures and spits out a ratio of y to x. Okay, the reason I mention this is a good way of understanding what the inverse sine and inverse tangent are going to do. The inverse sine takes in y over r and it spits out an angle measure, and the inverse tangent takes in one of these ratios and spits out an angle measure. So the reason I'm going over all this again is just to remind everybody that anytime I see this, this is an angle. It's an angle measure. It's an angle measure, and it's actually useful to give it an angle measure name. Let's call it alpha. All right? It's some alpha such that the sine of alpha is equal to negative 2/3. That's what it means to be the arcsine or inverse sine of negative 2/3. It's whatever angle measure I had to take the sine of in order to get negative 2/3. Okay, and that angle measure has to be between negative pi over 2 and pi over 2. All right. Similarly, this is an angle measure. This is also an angle measure. Angle measure. So let's call it beta. Let's give it a name that looks like something that would be an angle measure. And it's such that the tangent of beta is equal to 1/4. And beta is between negative pi over 2 and pi over 2. Okay, I guess I might as well put less than or equal to there. Sometimes people will just put less than for this one because tangent's not even defined when we're at pi over 2 or negative pi over 2, but that doesn't matter too much. Anyway, so what this is asking us to do, this is asking us to evaluate. So we need to evaluate the cosine of alpha plus beta, where alpha and beta are these angles here, described in these little boxes. All right, so this is starting to look like the same type of problem that we worked on in the previous video, the one entitled, what was it called? Adding the unknown. This is pretty much the same type of problem. Okay, so we're going to attack it the same way. One thing that is a little bit different here is I have set this up so that these numbers don't lead to nice Pythagorean triples like 3, 4, 5, and 5, 12, 13. These are going to be a little bit uglier in the execution, but I think we can still do this. Okay, so let's analyze alpha and beta. So I'm going to do that over here. We're going to analyze these geometrically. All right, so alpha going to lie somewhere on the unit circle, somewhere in quadrant 1 or 4, between negative pi over 2 and pi over 2. And it's organized so that, let's see, we know that sine of alpha is negative 2 over 3. So I'm going to call this negative 2 my y and this my r. Okay, so I'm going to put a point down here. That's going to be negative 2 in the y-coordinate. You're going to have some x-coordinate, and the radius is 3. So x squared plus negative 2 squared is going to be 3 squared. So x squared plus 4 equals 9. X squared is 5. So x has to be plus or minus square root of 5. Now in this case, because I know that my angle has to be in the 4th quadrant, not one of the other ones, that means x has to be the positive square root of 5, because the x coordinate is still positive. All right, so that means I know what my x is, all right, which may come in handy later. All right, let's also analyze beta. I'm just going to come down here to do that. Okay, so I believe I was given that tangent of beta was equal to 1/4. I'm going to call that y over x. So let's say that y is 1, x is 4. Okay, so I'm going to draw my circle. And you notice I don't know directly what r is. We're going to have to find that. Okay, this was not my best effort circle drawing wise, but forgive me for that. By the way, I know that one thing I need to account for is I know that beta is in the first or fourth quadrant. First or fourth. So, all that to say, both of these, y and x, both of those need to be positive. The only other alternative is that they're both negative. That would put us in the third quadrant. And that's not allowed here. That beta has to be between negative pi over 2 and pi over 2, because that's how the inverse tangent's defined. Okay, so this means that my y-coordinate is going to be 1, my x-coordinate is going to be 4, and I'm going to need to find the radius. But I think you know how to do that. X squared plus y squared has to equal r squared. So 4 squared plus 1 squared is r squared. That means r squared is, what, 16 plus 1? That's 17. So r has to be plus or minus root 17. And the radius of a circle is always positive, so that's going to be root 17. All right, so I have r equals root 17. All right, so now I have all these things around and can play with them. I'm going to shrink this a little bit so we can see everything at once. All right, so we want to evaluate cosine of alpha plus beta using all the information that we now have. All right, so I'm going to switch colors here. And I'm going to write down cosine of alpha plus beta. Now, according to my sum of angles identity, my formula for cosine of alpha plus beta, this is cosine alpha, cosine beta, minus sine alpha, sine beta. And you'll notice now I have everything set up so that I can find what I need out of all of these. Now, I already know, let's see, what do I already know? I was given earlier that sine of alpha is negative 2/3. I can go ahead and put that into this. Sine of alpha is negative 2/3. And the rest of these I'm going to have to work a little bit to find them. But I think now that I've done the geometry, I will not have to work too darn hard. Okay, so cosine of alpha, let's go over here. Cosine of alpha is going to be x over r for this circle. X over r, I now know that my x is square root of 5. My r is 3. So cosine of alpha is square root of 5 over 3. My cosine of beta, I'm going to come down here. Cosine of beta is going to be x over r for this circle. Let's see, x was what? X was 4, and r was square root of 17. So that's going to be 4 over square root of 17. I already have the sine of alpha. I need the sine of beta. Sine of beta is going to be y over r for this circle. And that's going to be, well, y is 1. R is square root of 17. So that's going to be 1 over root 17. And now I think I'm ready to calculate this entire mess. So this is going to be root 5 over 3 times 4 over root 17 minus negative 2/3. Don't forget there's a minus, there's a subtraction and a negative sign there. Over 1 times 1 over root 17. So what do I get? I get 4 square root of 5 over 3 root 17 minus, let's see, that minus and negative is going to give me a plus 2 over 3 root 17. So I believe that my answer is going to be 4 square root of 5 plus 2 over 3 root 17, which if you'd guessed that at the beginning of this video, I don't know, go and buy a lottery ticket. That's a heck of an answer there. And I'm not even going to bother trying to rationalize the denominator. I don't care very much about that. What I do care about is that I was able to find the exact value of cosine of alpha plus beta. Now let's remember what the original question was. The original question was find the cosine of this beast here. All right, it was this thing. Sorry, I had a little issue with my tablet there. It was find the cosine of this. Did I do that? I absolutely did. Because remember, this is the cosine of this angle. Remember, that's an angle plus this angle. And what I did was I just systematically found out everything I could about this angle and this angle using the geometry over here, using the Pythagorean relationship. And then once I had done that, I used the formula for cosine of alpha plus beta to write down everything in terms of cosines and sines of just alpha and just beta. And I substituted those in from the work that I'd done over here. Okay, so that's a little bit complicated. You may need to watch this one and maybe also the previous one a couple of times just to kind of get your head around the strategy, because I realized that I took some strategic steps that wouldn't occur to you on a first pass. But the whole theory, or the whole, I don't know, philosophy behind this, I think is the right way to put it. The whole philosophy is, this is a problem about some angles that I know very little about. So the first goal has to be to find out more about those angles. And if you keep that in mind, that these are angles and that we can learn more about them by using not the unit circle, but a circle of radius r, then you're going to make progress on this as long as you know these formulas.